is homework questions. Questions on any of the homework assignments? So, core concept, squaring each side of an equation. If two expressions are equal, then the squares are also equal. So if we put both sides to a power, they're still going to be equal. Now, we're going to solve this equation here. Now, there's a few steps. First step is there one radical? If so, get it by itself. If not, even them out. If so, get it by itself. If not, even them out. Once we do that, we're going to put both sides to the nth power. Step 3 is not going to come into play too much today or tomorrow, or 542, 543, we'll see that come into play. But 2, put both sides to the nth power. 3, are there any radicals left? If there's any radicals still left in the equation, we're going to go back and repeat steps 1 and 2. We're essentially just going to go through it and do it again. But once the radicals are gone, we're going to solve. So, when we look at this here, square root of x plus 5 equals 13. Is there one radical? Yes. If so, get it by itself. So we would indeed subtract 5. Showing us the square root of x is equal to 8. Is the radical by itself? Yes, so now we're going to put both sides to the nth power. So what power would we use? 2. Because we're squaring a square root. Because when we square a square root, the square root and square will simplify, leaving us with x. 8 squared, 64. Now when we square both sides or put both sides to an even power, we do not put the plus or minus. When we square root both sides or put both sides to an even root, we put the plus or minus. Because here we're saying what number, because we're taking the square root of it, there's only one solution with this here. When we have x squared equals 64, we have 2 possible choices. Now at this point we can check. Square root of 64 plus 5 equals 13. So second, square root 64 plus 5 is 13. Now part of the reason we don't have negative 64, there's not a number that times itself as negative. We can't have a negative. I was just saying that we can't have negative 64, it's just 64. Because when we square the number, square the value of x. I just checked it. And for the most part, when we check this, it's just square root 64 plus 5. We throw it in a calculator. Does it actually equal 13? Pull it back up. Square root of 64 plus 5 does indeed equal 13. Questions on this here? 3 minus the square root of x equals 0. Is there one radical? So we need to get it by itself. Telling us negative square root of x equals negative 3. Is the radical by itself? No, we've got that negative. We can divide by -1. We can multiply by -1. Either way, we get that the square root of x is equal to 3. Okay, radicals by itself. So we're going to put both sides to the nth power, and that nth power is 2. And the square root and square would cancel, giving us x by itself. 3 squared is, so x is 9. And again, I'm just going to check it. 3 minus the square root of 9 should equal 0. Bless you. Well, the square root of 9 is 3, and 3 minus 3 is 0. Questions on this here? Square root of x equals 6. Is there one radical? Is it by itself? So we'll put both sides to the nth power and then solve. Well, we would square. 6 squared is. So x is. Yep. Do we need to see another example of one like this? This here, x is going to be 100. And this is 49. So do we feel comfortable with these here? Okay. Yep. Goes here. Minus 15. All right. Let's look at this one here. 4 times the square root of x plus 2 plus 3 equals 19. Is there one radical? Get it by itself. Minus 3 from both sides. Telling us 4 times the square root of x plus 2 equals 16. Is the radical by itself? Divide by 4. Four divided by 4 would give us 1 times our square root of x plus 2, or just the square root of x plus 2, is equal to 4. Then we would square both sides. We'd put both sides to that nth power, because our square root and square would cancel, telling us x plus 2 is equal to 16. First one we actually had to solve for x, so we had to subtract 2, telling us x is 14. That's it. There is one radical, so let's get it by itself. We would add 1 to both sides. So 3 square root of x plus 5 would equal 12. Divide both sides by 3, telling us the square root of x plus 5 equals 4. Now we're going to square both sides. Square root and square would cancel, telling us x plus 5 is equal to 16. No radical, so we can solve for x. So x is equal to 11. Questions on this here? We feel good with these here. 4, 16, 12. All right. Solve an equation with radicals on both sides. for you and Bray?
Just for this hour.
Yep.
Thank you.
So this one here looks a little different, but let's check our steps and see what they say. Step 1, is there one radical?
No.
If not, even them out. So how many radicals do we have? 2. So if we even them out, we want one on either side. Yes? Do we have that? All right. Okay, let's go to step 2. Put both sides to the nth power. So we're going to square both of them. On the left-hand side, the square root and square would cancel out, telling us that we have 2x minus 1. On the right side, square root and square would also cancel out, telling us that we have x plus 4. Solve for x. There are no radicals left, so we're going to solve for x. So we can do what first? We can add 1. And then we would minus x. 2x minus x is x equals 5. Questions on this here? Square root of 4x minus 3 equals square root of x plus 9. Well, there's more than one radical, so we need to even them out. They are evened out, so we're going to do what next? Put both sides to the second power. Well, here, radical and square would cancel, telling us we have 3 equals 4x minus 3 equals x plus 9. What can we do next? We could add 3 to both sides. We could subtract x from both sides. 12. Divide by 3. That's it. I mean, if we wanted to check, we could. Because 4 times 4 minus 3, is that equal to 4 plus 9? Well, 4 times 4 is 16. 16 minus 3 is 13. 4 plus 9 is 13. And the square root of 13 is indeed equal to the square root of 13. It's not a nice number, but they are equal. Questions? Do we have one radical? No. If not, even them out. Are they evened out? No. Now, I will say, what I'm about to write, don't write. If you already started solving it, it's fine, because we are going to have to move it. Now, part of the reason I say even them out is we can solve it without it. We could go on and put both sides to the nth power. Now, the right-hand side's nice, because 0 squared, 0 times 0 is 0. The left-hand side, if we left it this way, we would have to take this term, this whole expression, the square root of 3x plus 1, minus the square root of 4x minus 7, and multiply it by itself. Because we have that addition, or here, subtraction sign, we would have to FOIL this whole thing out. But especially if we have two terms, what we can do is I can add the square root of 4x minus 7 to both sides. Because negative square root of 4x minus 7 plus the square root of 4x minus 7 would be 0. telling us that the square root of 3x plus 1 equals the square root of 4x minus 7. If one of the two radicals is negative or is being subtracted, add it to the other side. Because it'd be nice if both of those radicals are positive in front of it. Now, since we have them evened out, we're going to put both sides to the nth power. And because it is an individual term, it's not two radicals being added or subtracted. We're squaring. Essentially, we're still doing the same thing. But when we square a square root by itself, they do simplify out, telling us that we have 3x plus 1 equals 4x minus 7. Telling us 3x is equal to 4x minus 7. Then we would subtract 4x, telling us negative x is equal to negative 7. Well, if negative x equals negative 7, positive x should equal what? Ah, yes, thank you. Brain spaced out a minute. So, negative 8. If negative x equals negative 8, what should positive x equal? Or we could say that we multiply both sides by negative 1. Negative x times negative 1 is x. Negative 8 times negative 1 is 8. We could also divide both sides by negative 1. But either way, we get x is equal to 8. Questions on this here? I think this one ends up being 1/4. All right. Let's look at this one here. Is there one radical? So get it by itself. Put both sides to the second power, yes? Well, wait. That's not what the step we had is. What does the step say? Put both sides to the what? Nth power. So what would our nth power be? 3. We cube it. That is why I put nth power, not second power, because again, whenever we have these radicals, we're going to put it to whatever the index is. Since the index is 3, we'd put it to the third. If we'd taken a fourth root, we would have put it to the fourth. As a cubed root and third power will cancel out, telling us 5x minus 2 is equal to 1728. Yes. There's no radicals left, so we can just solve for x. Add 2, telling us 5x. 1730. Divide by 5. Questions on this here? Let's do one more. Cubed root of 2x minus 5 equals 3. One radical on both sides. They're by themselves, so we can cube it. Telling us qx minus 5 is equal to 27. 3 squared, 3 times 3 is 9. 9 times 3 would be 27. Then we would add 5. Qx equals 32. And that's it. Questions on this here? That's it. 15 problems.